fair warning, this is going to be a long video whilst I go through the minutiae of taking a model through CAD, through CAM, decide on toolpaths, generate them, take them to machine and run it. If that's not your kind of thing, go check out some other videos. If you think that might be useful to you, stick around. Hi, this is MakerGeek and I'm Dan. This week on the MakerGeek Facebook page, I was reached out to by Kevin, who asked me what my workflow is for going from CAD to CAM to CNC. So this is a video for you, Kevin. You also asked about specifically going from a DXF file to a CNC pattern. I don't normally do that because I tend to model everything myself, but for the purpose of this, I will first go and grab a DXF file. So first things first, thingiverse, let's do a quick search for CNC and DXF. So CNC DXF. So let's see if we can find something that's interesting to make. This looks kind of fun. Let's have a look at you. So here we have a planetary gear thing. That looks perfect for our purposes. So let's see, files, planetary card large DXF. Let's download our DXF file. Okay, so I use Fusion360 for everything these days. So I'm just going to start a new project. I'm going to save it as Kevin Test. And I'm going to go to Insert DXF. So I'm going to select the plane that I want to insert onto. I tend to select the front plane for most things, it doesn't really matter. And then I'm going to select the DXF file that I just downloaded. Planetary card large. Let's have a look at how this comes in. And there we are. One layer. So now I've got a DXF file in Fusion360. It appears as a number of lines here, and what I want to do is, I could probably just do this by cutting out straight into CAM, but for the purpose of modeling, I'm actually going to extrude these shapes to give them depth, and then we'll talk about the CNC machining part. So I want to cue to extrude. I have some 9mm ply, so I'm just going to extrude all of those. Now you'll notice the first thing that it does is it disappears all of the rest of the drawings. By default, when you extrude from a sketch, it hides the sketches. So I've just unhidden the sketch again. Let's extrude some more. Let's do this. So this is a nicely structured DXF file. All of the shapes are linking up nicely. I guess this I want to extrude the interior like that. Then and last one. Okay, so let's now hide the sketches. So now I have a bunch of parts which are all massive. Did I not extrude those to 9mm? Did I just do those as 9mm? Wow, these are tiny. So I think that, so I guess this is the first interesting example. I'm pretty sure what's happened here is that on the DXF import there are a units mismatch. So because like this would be very, very small parts, and I'm pretty sure that's not how it was intended. As in this would be less than I would guess. Let's just do this again. If I just check from here to here. Yeah, that's 7mm, less than 1 centimeter That's clearly not right, so we're going to scale these up, I suspect, 10 times. Which is interesting, right? Because this is actually going to give me an interesting opportunity to show a Fusion 360 feature, which is I've just gone and extruded all this stuff from drawings. Now I want to scale those drawings essentially before I extrude it. So I can drag my timeline here back to before the first extrusion, switch my sketch back on. So now I'm back to the time before I did anything. Let's select everything and let's do modify, scale. Okay, lots of entities. Let's select a point. I'm going to select point at origin, and I'm going to scale everything by, let's say, 10-fold. So that will give us a 7-centimeter sketch, I think. Right, so let's inspect it now from here to here. Yeah, so that we're now at about 7 centimeters, which is still not very big. You know what, I might even scale that a little bit more. I want to end up with something I think that we'll say is about 15 centimeters. That seems like a reasonable sort of size. So let's just scale that a bit more. 2. Okay, so let's just verify that measurement. So yeah, 140 mil, 14-ish centimeters. Okay, so now I'm happy with the size. Let's try rolling back to after all those extrudes, and hopefully magic happens, which is it remembers all of the things that I had selected to extrude, and it remembers the depth that I wanted to extrude them to, but it is now adjusted for the new shape. That is pretty damn cool. Time for CAM. So we've got our shapes, and we have a layout. In fact, let's see, what's the from the very tip of that to the very tip of that, we're about 40 centimeters, about 45 centimeters, I guess. That's not bad. Let's see, from here to here, yeah, I think we're probably right. So, first thing we want to do is create a setup. The setup, in this case, is going to include all of these elements, which is fine, but obviously if I wanted to machine just parts of some of them, then I could deselect them, but by default it's selected my 10 bodies. The next thing I want to do is check. So stock, it's put a 1 mil offset on top, so it thinks it's 10 mil, that's safe. That'll just give me a chance to deal with any slight non-flatness in my stock. And the overall thing is going to be 243 mil wide by 450 tall, which actually is perfect for my CNC machine. The only other thing I want to do is select where my origin comes from. I personally like generally to set my origin at the bottom side, kind of left corner. And if you see my video on using the probe with the OX, that's because I will probe down to the surface of my bed, and so I know that the material is above that 0. I tend to find it's more reliable about me not machining into my CNC bed. Okay, so now we have our stock set up and all of our objects in there. We're going to quickly make sure that we've got the sketches switched off. I don't want to accidentally select any of the sketch lines. I want to be selecting the exterior of bodies. I've had that problem before where you can accidentally select a sketch line, but then the machining operation doesn't look like it's doing the right thing. It kind of plunges into the middle of your parts. So 2D contour is probably what we want, because we're mostly just going to cut this out. We're going to select a tool. I'm going to go with my 3mm 2 flute bit. I'm going to set our RPM whilst we're here, probably 15,000 will do it. Let's take a 2,000 millimeters a minute passes. Now we want to select the geometry. So yeah, you can see you just get these lines up here around the outside. You want to make sure you select the bottom profile of all of your pieces. So that's all the major piece is selected. I'm not going to select any of these interior pieces yet, and I'm not going to work with drilling any of the holes yet. Let's just get the principal stuff done. I'll start with letting it do auto tab creation. 3mm by, I probably want a bit more than that. Let's give it 2mm heights. That just to help everything hold into the finished piece when it's cut out. I don't want it to go flying off the machine. Let's see. The other thing I want to do is take it in multiple passes. I don't tend to try to cut that deep in one go, so let's try 2mm passes, and well, let's just see what that generates. And there we are. So you can see we've got lines around everything. That looks pretty good. Let's just simulate that quickly. So I simulate with stock on, just to see what we look like. So speed that up. You can hopefully get an idea for what gets cut out. Not too bad. We might have some trouble with the gear teeth in here. The 3mm bit probably can't get that deep into those, but it'll probably do. So that's the main contour operation. Now we're gonna think about taking these out. Now, depending on the size of these kind of sections, sometimes you want, it's nice to contour out because you don't have to cut away all the material. Sometimes it's nice to hollow out. Let's have a look at pocketing. Let's just assume we're going to pocket these. Okay, default 3mm tool still. Let's have a look at what that does. So, wind down into each of them. Again, let me multiple depths. 2. Now what you could do here is leave some stock. You want to decide how clean you want this interior surface. Well, let's assume, in fact, let's do this for the purposes of demonstration. I'm going to leave 1mm stock on the interior profile. So this is just going to come in, hollow those out, but it won't come as close to the wall as possible. So that's pocketed those. So I just want another contour. Let's copy the contour. Get rid of all of those chains. So this is a contour that doesn't need tabs. Don't do that. So in theory, this is now just going to be a finishing pass that will take that last millimetre off the wall. I'm going to give that a go in a single pass, which will hopefully give me a nice clean finish. Actually, it's already, I copied it from there, so it's going to do it in multiple passes. Let's take off multiple passes. We'll do conventional milling. Okay, so that'll just plunge into each of those and clean up those holes. So the other thing we want to do is drill out the holes, and there are a couple of options for drilling out the holes for connection. You can mount a drill bit, or you can bore. So let's, first to begin with, I'm going to have a quick look at what it takes to potentially bore these. So let's have you. Oh, that's interesting. That interior cylinder is constructed of multiple pieces. see what that does. Oh, it doesn't like that at all. Okay, well it seemed to give me, I just had that. It basically has to do the same thing. So for the moment, so it can do that with a 3mm bit. Let's have a look at this one as well. That's the same situation. Okay, so that's just two boring operations. And then I don't know what size all of these sections are. Let's just inspect. So that is, that is a 2.5mm hole. Okay. I don't think that's super necessary. That's just for holding these and aligning them together. I think I'm probably just going to make these 3mm holes. So what have we got? Pockets, clean up. Oh, come on. There we are. Then bore, then cut out. So that leaves me with these corner holes not done, and they're quite small and I don't really want to have to do a tool change. So, peck drilling, that's what we'll do. Okay, so we'll take these small holes out with a peck drill. So I'm kind of cheat here. I'm not actually going to change to make a smaller drill bit. I might just leave the 3mm in, but obviously a 3mm end mill isn't really designed to drill because it has kind of a flat base. But I'm going to cheat and use peck drilling. So it's going to go down 0.7 of a mil. Peck depth reduction, minimum pecking distance, accumulated pecking depth. Let's have a look at what that does. So let's just quickly simulate you. So that should take care of those holes. They'll end up slightly bigger than in this, but I don't think that's critical. So let's talk about order of operations. I want to do basically cutting out last. So let's just drag him down to the bottom. I'm going to do this one first because if that doesn't go very well, then I should be able to detect it on the first hole and kind of give up with relatively little damage. But let's see. So we should do drilling, then we'll rough out our pockets, clean up the edges, bore the slightly wider holes. That will kind of come in a helical pattern down. Then we'll cut out. So that is the job or operation. So I have a few choices now. When I save it, I can save them as each individual steps as a separate file, or I can batch them into two different things, or I can do one giant file for everything. Depending on what I'm doing, sometimes I split them up, sometimes I don't. The advantage of not is that you just load one file and off it goes. But sometimes it's nice to be able to repeat steps if something goes wrong and you end up having to come back and save it separately anyway. For now, I'm going to save these all as one file. So to do that, I right click on my setup, I say post process, and let's create a file folder. Kevin test. And then inside Kevin test. So we're just going to save it out. Now this Fusion360 has a bunch of different post processors. I've selected the one for Gerbil specifically, which is on the OX. That just makes sure that it uses commands that Gerbil understands, and we'll post. So it doesn't really matter what the file name is on this case because I'm not differentiating the different steps. So that saved that out. So that saved that file. Now I'm just going to SCP that file to my Raspberry Pi over the Wi-Fi so that when I go downstairs it'll be available to load. So let's go do that bit. So here we are down in the workshop, ready to start going. So my OX CNC is connected to a Raspberry Pi, which is screwed to this piece of wood down here, and I just run it off this monitoring keyboard stand right next to the machine. On the Raspberry Pi I'm running BCNC as a control software, and this was the thing I did last weekend. So essentially I just want to open my new file, which is in the Kevin test folder. So let's open that up. This is it loaded. Let me just zoom in on that a little bit. Now you can see, interestingly, that the rendering on BCNC doesn't always render all of the parts. That doesn't mean it's not going to do them. I think there's just something in the way the rendering engine tracks what it's doing. For the moment I'm going to trust that it is going to do everything I want. So we can see that yes, the axis is where I'm expecting it to be. The home is down here. It currently shows me that it thinks the tool is over here, relevant to where the current XY0 is. That's basically a holdover from the last job, which is probably going to be pretty close to where I want it, but I will always reset. So next part of the job, I've just come down to the machine for the first time this weekend. I basically always run a homing cycle, so let's home. So now we've gone home, I want to move out to essentially what's going to be my XY0. Since I've added a vice to my machine, that's a little further over, so I'm going to say let's move in steps of 100, and we're right. Let's have a look at that. Again. Okay, so that's about where I want it. Now I'm going to steps in 10 back and down. Since I've put my vice in place, I have not yet reset my probe touch-off point. For this, it's only one pass with the same tool. I'm not going to do any tool changes, so I'm just going to mark 0 off the bottom here by I. That'll do. I've got to a point, and in fact, you can see it hasn't lost position since the last time I ran a job. It actually does think that it's at Z0. If this was off of Z0, then I would just hit this button at this point to say that the Z height is now where I think it should be. And we can see that we are -3 off of the X0 and -9 off of Y0. Again, I think that's probably fine. Essentially, I'm using the same sheet of plywood as I used last weekend, so as it happens, I don't really need to change these. But normally I would come up over to where I want to be, basically position the tool over the material where I want Z0 to be, and then I would just hit X0, Y0, and we'd be good to go. In this case, this is close enough. At this point, we have the router positioned, we've got our job loaded, we're reasonably comfortable that everything's going to go, so it's a case of set up and go. Now, my G-code, I don't know actually how to do it, so it never waits for the router to spin up to speed, so I always start the router manually. So although it can start the router, and it will, and it certainly can stop it, it starts and just assumes it's instantly at speed, which it is not. So it's better to manually start it, wait for it to be up to speed before you start the program, just so that you don't end up hitting the wood before you're really going fast enough. BCNC has these manual controls. So spindle, you can set what you want the RPM at. I set it at about 15,000 in the program. So I will do that, click it, and you can hear that that is spindle starting up. Then okay, I can hear that it's up to speed, so I now just click start. Took kind of a lot of finishing by hand. I ended up sanding the middle discs down one layer so they would be a contrasting colour. I think this probably could have done with doing a 2mm pass to get a little bit more of the detail out, or I could have scaled it slightly larger. That's the kind of issue that I tend to not face so much when I model my own things, because I keep in mind what size bits I have. And so that's sort of represented in the model from the beginning. But overall, it went okay. If I was going to do it again, I would probably tweak the toolpaths a little bit. The whole thing took about an hour, I guess, to cut out, which isn't too bad as far as CNC jobs go. I hope the workflow was informative and you didn't get too insanely bored. Thanks for watching. See you next time.